For the first time, there is a rocket that can make all life multiplanetary, a fork in the road of human destiny. Elon Musk tweeted this on X, referring to the Raptor, SpaceX's most powerful in-house developed engine. To date, SpaceX has advanced to the third generation of this rocket, marking a significant milestone in the Starship program and setting a new standard for engine power in the aerospace industry. Let's find out everything in today's episode. In the world of aerospace technology, it's no exaggeration to say that the engine is the heart of a rocket, the very symbol of technical innovation. Recognizing this, SpaceX has invested significant time, resources, and capital into advancing the Raptor engine line. Now, we have the third generation of the Raptor engine, and it's nothing short of a modern engineering masterpiece, featuring these impressive specs: thrust, 280,000 pounds force; specific impulse, 350 seconds; engine mass, 1,525 kilograms, and a combined engine and vehicle-side hardware mass of 1,720 kilograms. At first glance, it's sleek and shockingly simple. Historically, rocket engine designs have been bulky and intricate, a maze of pipes, valves, and components that left everyone convinced that complexity was just the nature of the beast. Yet, Raptor 3 stands as a rebellion against every old technical norm. It embodies the philosophy: perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. So, what makes Raptor 3 so remarkably simple? A significant part of Raptor 1's complexity came from its extensive sensor system. Sensors for temperature, pressure, vibration, and countless other readings were scattered throughout the engine. With the earlier engines, the engineering team aimed to integrate as many sensors as possible to gather a wealth of data on internal operations, allowing them to understand and optimize every detail. But over generations of development, the team gathered enough data to deeply understand the engine's behavior. The valuable lessons learned from these tests enabled SpaceX to design an engine that no longer needs sensors at every tiny point. With Raptor 3, only the truly essential sensors remain. Furthermore, Raptor 3 has been engineered with an internalized approach. Engineers moved many external components inward, streamlining and consolidating the design. As Elon Musk explained, all the small plumbing and wiring had to be deleted or incorporated into the primary structure because Raptor 3 will have no heat shield. Also, all parts need to be actively cooled in some way. So we added regenerative cooling, where there was no existing fluid or gas flow. That's regenerative cooling at work, something I've covered in previous videos. But this picture gives you an even better look. According to images shared by SpaceX, Raptor appears jet black, but here you'll notice some white patches. Musk explained it simply: the parts that appear white are actually black, but covered in ice. Raptor runs on liquid oxygen and liquid methane, both kept at extremely low temperatures. As fuel flows through the engine's piping, it chills the surrounding surfaces, causing water vapor in the air to condense and freeze into ice. This is a natural effect of regenerative cooling and visual proof that the engine is staying cool. Now, beneath its sleek exterior, Raptor 3 still has those intricate pipes that help keep its temperature stable throughout its operation. In earlier versions, with these pipes on the outside, like Raptor 1 and 2, they were highly vulnerable to extreme heat and physical forces. To protect them, SpaceX had to add heat shields. But with Raptor 3, those previously exposed pipes now lie within the engine, and they are effectively used to protect the core instead. That's what I'd call a perfect case of two birds with one stone. This design embodies Musk's philosophy. The single biggest mistake made by smart engineers is optimizing a thing that should not exist. Musk proudly shared more on social media, saying, "The amount of work required to simplify the Raptor engine, internalize secondary flow paths, and add regenerative cooling for exposed components was staggering." As a result, Raptor 3 doesn't require any heat shield, eliminating heat shield mass and complexity, as well as the fire suppression system. It's also lighter, has more thrust, and is more efficient than Raptor 2. Truly a work of art. This is a bold testament to SpaceX's remarkable technical achievement. This success is deeply tied to SpaceX's advanced manufacturing capability. To produce Raptor engines, SpaceX has invested heavily in state-of-the-art 3D printing technology. Musk has shared that SpaceX owns some of the best metal 3D printing tech in the world, including laser beam powder bed, fusion PBFLB, and directed energy deposition DED, two of the most widely used metal additive manufacturing processes at SpaceX, though details are still sparse. The company is likely operating highly customized variants of market-available additive manufacturing and post-processing technologies, along with some homegrown solutions. After all, SpaceX has a reputation for technological independence. Although Raptor 3 has yet to fly, we've already seen it undergo several successful test firing, and I've never doubted its reliability. The Raptor's dependability has only increased with each new generation. Recently, at the McGregor test facility in Texas, SpaceX conducted an extraordinary test where they fired a single Raptor engine 39 times in a row. You heard that right, starting and stopping an engine almost 40 times. This test far exceeds any operational demands in a real launch mission. There's no scenario, emergency or otherwise, where a Raptor engine would be required to perform at this level of intensity. This could very well be a stress test, likely to verify ignition reliability and assess the engine's endurance. It also hints at SpaceX's ambition to one day see boosters capable of multiple flights within a single day. Or perhaps the company simply wants to test the engine's reignition capability in case of an emergency. When an engine fails to ignite at a critical moment for any reason, the ability to restart immediately could mean the difference between mission success and failure. This calls for an extremely robust, reliable ignition system and a profound understanding of the engine's behavior under extreme stress. From the moment Raptor 3 debuted, it quickly earned industry praise for its sleek, simplified, and highly efficient design. However, this success hasn't come without a few biting comments from competitors. Tory Bruno, CEO of United Launch Alliance, posted a somewhat sarcastic remark on X. They have done an excellent job making the assembly simpler and more producible. So there is no need to exaggerate this by showing a partially assembled engine without controllers, fluid management, or TVC systems, then comparing it to fully assembled engines that do. Elon Musk's response? A succinct "LOL." And Shotwell followed up with a picture of Raptor 3 firing, paired with a graceful response. Works pretty good for a partially assembled engine. It turns out Bruno made a fundamental misunderstanding. The Raptor 3 featured in SpaceX's images isn't some incomplete engine, as he thought. In reality, it's a fully completed engine, just a more streamlined, adaptable version. Raptor 3 was designed to be used in different positions across the Starship rocket. For the 20 outer engines dedicated purely to thrust, a thrust vector control TVC system isn't required. These engines are intended for simpler operation, reducing overall complexity. However, for the gimbaled engines responsible for controlling and steering Starship, TVC systems are added later when necessary. This modular design allows flexibility and cost-effectiveness, reducing overall complexity and simplifying production. The basic model, shown without a TVC system, represents the core engine, which can easily be customized for mission requirements. Tory Bruno's displeasure over Raptor 3's launch is understandable within the current landscape of rocket engine development. ULA purchases the BE-4 engine from Blue Origin, and when Blue Origin decided to sell this engine, they had to lock its design. This means that while the BE-4 has reached stability, it's still not fully optimized. With the design locked, the BE-4 can't undergo further refinements and will maintain its current configuration. If Blue Origin wants to achieve a more optimized engine, they'll need to develop an entirely new engine line from scratch. While the BE-4 remains as is, SpaceX has no plans to stop at Raptor 3. Elon Musk has hinted multiple times about the development of Raptor 4, a next-generation engine with an astonishing thrust that could reach up to 330 tons. This would be an incredibly powerful engine, giving SpaceX a decisive advantage in the space race. There are two main ways to boost a rocket engine's thrust: increase the throat diameter or raise the combustion chamber pressure. From Raptor 1 to Raptor 2, in addition to increasing chamber pressure, SpaceX also enlarged the throat diameter by about 7%, allowing significantly more fuel and oxidizer to flow through. The result? An impressive leap in thrust, jumping 24% from Raptor 1's 185 tons to Raptor 2's 230 tons. Interestingly, the throat on Raptor 3 appears narrower compared to Raptor 2, possibly closer to Raptor 1's dimensions. The objective behind this change may be to reclaim about 3 seconds of specific impulse that was sacrificed with Raptor 2. So, if they continue this trend with Raptor 4, we might not see another increase in throat diameter, but rather an increase in chamber pressure. Raptor 3 already operates at 350 bar, a higher pressure than any rocket engine ever used, meaning Raptor 4 could push these limits even further. I can't help but wonder what kind of materials SpaceX is using to build Raptor. These materials must be unbelievably strong and durable. Given the design trend we've seen across Raptor generations, it's likely Raptor 4 will be even simpler. However, it's hard to imagine what else they can streamline. And without a doubt, once Raptor 4 is released, it will stand as the best engine ever created in the history of the space industry. Right, that's it for today. If you enjoyed this video, please give it a thumbs up and subscribe to our channel for more in-depth looks at the latest advancements in space technology. Thanks for watching, and I'll see you next time.